Good morning, ladies and gentlemen. A very warm welcome to all of you as we gather for this important webinar series on 100% electrified buildings and communities for climate governance Malaysia in collaboration with the US Embassy. It's also proudly supported by Greenway and Malaysia Green Building Council. I'm honored to be your MC for this exciting event. Our aim is crystal clear: to enhance efficiencies at scale and pave the way for electrifying homes, commercial buildings, and communities across Malaysia. We recognize the urgency of addressing climate change and the pivotal role electrification plays in our sustainable future. I encourage you to engage with the panelists, share your thoughts, and leave questions on the Q&A chat box, as this is an opportunity for us to learn from each other. Thank you for being here to join us on this third session of the series, Empowering Sustainable Communities, Communities Charged for Change. Now let us pass the floor to Dato Seri Johan Raslan, Council Member of Climate Governance Malaysia and Director of Sime Darby Property. Over to you, Dato Seri.
Thank you very much, Sharon. Good morning from Malaysia, good evening from the US, and good middle of the night from Europe. My name is Johan, and I'm here to bid you a warm welcome from CGM, or Climate Governance Malaysia. Climate Governance Malaysia is the Malaysian chapter of the World Economic Forum's Climate Governance Initiative, and we are a network of non-executive directors of companies. We aim to acquire the practical skills needed as long-term stewards of companies to steer our companies through an effective climate transition strategy, taking into account the need for financial stability, increased resilience, and sustainability. We put on a range of events with the intention of raising awareness of climate emergency that we all face, especially us in Southeast Asia. Our events range from more intimate ones like today's, to up to hundreds of participants like our climate summit that we held just a month ago. Today, we and the Embassy of the United States of America end a remarkable three-part series of discussions aimed at transforming the way we power our homes, condominiums, and apartments in Malaysia. So it's really personal and relatable to each of us. Throughout the series, we have had valuable insights from experts, thought leaders, and innovators in the field. And today promises to be just as good, and maybe even better. Eminent colleagues, I'm conscious that I am standing between you and knowledge, and that is unsustainable. So, let me hand right over to architect Serina Hijjas, President of Malaysia Green Building Council, and someone, well, I consider to be one of Malaysia's preeminent architects. We're very lucky to have her. Serina, over to you.
Thank you very much, and a very good morning to everybody. Good morning, Johan from the UK. I think it's about almost 2 o'clock in the morning over there. And good afternoon to Sean. Let me introduce you to our keynote speaker today. Sean Armstrong joins us live from California, United States. Sean Armstrong is the managing principal of Redwood Energy and has worked for 28 years in building electrification, designed the retrofit and new construction of more than 25,000 all-electric residences for disadvantaged population, co-authored 7 pocket guides to building electrification, provided legal and technical support to building gas bans nationwide, and has received grand prize awards from the United Nations and the California Building Industry Association. Sean was inducted into California's Clean Energy Hall of Fame in 2022, and in 2023 and 2024 is working with other nations on their net zero goals on behalf of the US State Department. So we're very, very excited to hear, and do take a glimpse into Redwood Energy to see his extensive work guides and work in this field. So Sean, I welcome you to the stage.
Thank you very much, Serina. And thank you to the United States Embassy and the State Department, and thank you to the embassies of Malaysia. This is a real honor. I get to brag to everybody. So thank you. Tonight I'm going to talk a little bit about community and societal scale electrification, and I'll be focusing on transportation. My co-guest is going to be focusing more on buildings. So just briefly, I grew up on a farm I always wanted to be a scientist. I started being a science high school teacher, and then I went into being a sustainable farmer. I have, like, as a side gig, I'm really into farming animal, livestock, and fruit trees sustainably. But I focused on affordable housing, which were places where there were financial incentives to electrify and solarize at the same time. And so I became a leader in North America on how to do all electric 100% solar powered housing. And one of my cool projects is this one on the bottom that has a 9-story tall solar wall, and it's affordable housing for low-income seniors in the nation's capital, Washington, D.C. So just getting right into it, I want to show you a few examples of buildings. I thought this is one of the most amazing large examples of an all-electric hospital complex. And I know it's all-electric because they replaced electric resistance boilers with heat pump boilers. And Hong Kong, like so many islands, has limited access to natural gas infrastructure. It can be difficult to get it across waterways. So a lot of all electric construction there. So big facility. And I just want to note that buildings like literally large hotels, you'll find them. This is on the left-hand side, this is the Ritz-Carlton at Waikiki Beach. On the right-hand side, this is the Asiana Plaza Hotel over in Vietnam. And these are also both buildings that used central heat pump boilers. So that's one of the ways to track them down, is who is buying these products. And they're using them both for their swimming pools and for all the dishwashing and all the showering. So they've electrified. Now, focusing more on vehicles. Just whet your appetite for the next building part of the talk. So tractors, the Monarch tractor, you can find this in Malaysia. Actually, pardon me, its autonomous capabilities were developed in Singapore. So neighbor, the Monarch is available there. It's available here in California, and I think that if you recruited it in, just to note that tractors are polluting, and anything that is using gas breaks more than an electric version of it. So it's one of the things that can really increase productivity on a farm, is to get people out there getting their work done in electric tractors. This is what it looks like a little bit up close, and you can see its charging equipment there on the wall. So here you have Terberg. It is introducing the YT2000 EV fully electric terminal tractor. So this is the kind of big vehicle that moves around large amounts of heavy other things. So they're saying it's cheaper to operate than paying for fossil fuels. This 350 kilowatt hour battery, that is a very large battery. If you're using it for other purposes, like you might be able to power 20 or 30 houses off of that for days at a time. But when it's hauling around really heavy things, it operates for 10 hours, and then you generally charge it overnight. But you can do just 1 hour fast charging. It takes a lot of electricity to fill up a 350 kilowatt hour battery. Well, it takes 350 kW, and it can haul around 90 tons. And here on the tiny scale, this I think is really fun. These scooters, they're getting around the issue of charging by doing a swap out of the batteries. So you can see that the first, this is a Blue Shark, they're beginning to deploy this, and they're doing it with Petronas. So you can find it, the Petronas Batu Tiga on the Federal Highway. First 4 locations, but they're not alone. Here's another one. So Taiwan, just mentioning here on the left-hand side, is a mature battery swapping out system. So then over here on the right-hand side, you can see it being announced it's coming here. 2 Malaysian companies working together on battery swapping technology. So Ni Hisin EV Tech and MNE Energy have partnered to develop their own battery swapping technology. So it's spreading. And this is just a nice way, scooters are affordable, and the only downside is the batteries. Point out that anytime you're storing a battery, just like if you're storing gasoline, it is potentially a flammable thing. I like the fact that they've got these really professional, well taken care of battery systems. Just, I think batteries should be taken seriously as a thing to do right. So the food companies are getting into the business. Grab Food in Malaysia is going electric thanks to EP Manufacturing BHD. So the plan is to get 80,000 drivers converted over to electric vehicles. So they've got two phases. Initiative 1 is donating 50 of these little scooters. Initiative 2 is providing EVs and battery swaps at a discount to Grab drivers. So that's how they convert over 80,000, is making it a lot cheaper for them to drive that way. Pardon me, I have to take a drink of water. My throat is a little dry. So I have a coffee mug from 1962 that has the Live Better Electrically logo on it. That's what I drink when I'm doing my little talks. We are not the first people to think it was a good idea to get clean vehicles and clean buildings. Clean industry. Over on the right-hand side, you can see Food Panda partnered up with NHEV Tech. Just adorable. It's fun to see these initiatives. Now, you might be thinking, oh, 80,000 EV motorcycles. That's really ambitious. It is not. If you go to China, as my co-speaker will be maybe be able to speak to, but you can see here from the photos that there are just rows and rows of EV chargers. And I've seen fun videos of the streets of Shanghai and Beijing where you just don't see any gas scooters, just all electric going by. Well, one of the ways that is a best practice to think about in Malaysia as the EV scooter technology is the EV charging happens as it expands, is just look at all the different kinds of plugs that are available on the lower right-hand side. This is a best practice, is just to assume that we're not going to all have the exact same standard plug anytime soon. I think that computers and cell phones have taught us that there's not just going to be one charging technology, maybe ever. So best to just build in a diversity from the beginning. Then, just to celebrate what's happening here in Malaysia, you can see that, countrywide, EV infrastructure is coming on. It's coming on fast. So one of the examples is Yinson's Charge EV network. So they're starting on 359 charging stations between Malaysia and Singapore. Now in June 2023, so this is recent news for folks, they signed a memorandum of understanding with Plus Malaysia, and they're also then developing a hyper-powered DC hub, which just means exceptionally fast 350 kW charging. I mentioned earlier that there was a vehicle that had a 350 kW battery. I think it was where was that? Here we go. This is a 350 kWh battery, this huge hauler arounder. And I was like, wow, 1 hour of fast charging. Well, that's what they're putting in here, is something that could fill up that big of a battery. Something that's going around for 10 hours a day, hauling around 90 tons or whatever. Just ridiculously fast charging for ridiculously big batteries. These kinds of chargers are what you put in for semi-trucks. And that's exciting to see, is that essentially the infrastructure is being laid for long-haul trucks in Malaysia right now. Now, laying out infrastructure is difficult. There was the video at the beginning of our session that had the investor. He kept on pointing out that it'd be a good investment opportunities if we did what he was suggesting, which is replace everything. All the wires, all the appliances, everything has to be replaced. Isn't this a great investment opportunity? Yeah, for him. But for you, it is proven time and again that it can be cheaper to put up a solar panel and battery in a place and have that be the EV charger, rather than trying to extend heavy-duty wires all the way to that place. And yes, it means that this EV charger maybe can only be used half as much or 1/3 as much as an EV charger that was directly hooked up. But you might be able to put 2 or 3 or 4 or 10 more there than you would be able to do if you had to try to deliver this massive amount of electrical infrastructure wires and power plants, etc. So acknowledging this tension between what the investors want, which is brand new, expensive everything, and what people need, which is a way to charge their car. They didn't need all the rest of that. We have these like standalone solar and battery EV chargers. So Petronas, a subsidiary of Gentari, is trying to address this concern. And these are not completely off-grid, so meaning they have a trickle charge using the existing infrastructure. So the solar is feeding in, trickling into the battery, or maybe pouring in during the day, but more or less feeding in slowly. And there's some slow electricity coming from the grid, and combined together, a very cost-effective solution for charging a battery to then charge EV batteries quickly. So the goal there, you can see the grid connection will only be used at night if the batteries are depleted. So they're not even trying to use the grid connection unless it's necessary. This is just another example of it. This is the first chargers located Temasya, Petronas Station along the Federal Highway. And it's part of EMERGE, which stands for Enabling Mobility Electrification for Green Economy. And so this has a 50 kW EV charger. I showed before, they're setting up 350 kW. 50 kW is fast. It fills up a car that can go a few hundred miles, and it fills it up in about an hour. So just another example. I like how we're also starting to see electric vehicle ride sharing. An affordable solution is an electric scooter. An affordable solution is sharing an electric car. So in 2015, Comos started Malaysia's first electric vehicle car sharing program. And they discovered that customers were more interested in checking out the electric vehicle just for the day, rather than like multiple days and short trips and things. So one day they discovered it was the sweet spot. And so now they offer personal electric vehicle rentals and corporate leases, so targeted around the one day. And when the cars arrived at that low mileage spot, like might be 10,000 to 30,000 miles, depending upon how rapidly they want to keep up the cars, then they can cycle them out. And an interesting thing that we've seen in the United States is that we have one of our very largest rental companies is Hertz. Hertz came out recently and said, our electric vehicle fleet is by far the most profitable part of our fleet because they're on the road 60% more, meaning they're not being delayed by having to have any kind of fluids changed, anything that's a gear or all these different moving parts that can break. There's so many different ones in an internal combustion engine and the way that delivers energy. So overall, what they're finding is that these are just like small electric cars, like the toys you played with when you were a kid, and there's not a whole lot that breaks on them. I was just noting, is there anything in the chat? Oh, okay. Yeah, you got instructions on, you can address questions towards the end. And okay, so the cars can be leased out. Now, some of you might have seen this slide before, but I am so excited about this that it bears mentioning. I'm going to bring it back up a couple of times. So societal or community electrification, it's not just a one-way street where we have to plug the cars in and they get charged. Instead, we can plug the cars in and they charge things. So this is an example of bidirectional charging. So in both ways, the vehicle can participate, either taking electricity in, and in this case, this is a parking garage in Utrecht, Netherlands, where they're trying to go for an entirely renewable grid fast by having about 15,000 bidirectional chargers is their target, but they've got 1,000 of them installed now all throughout the city, where basically they're saying these cars, there's so much battery there that they could be storing the wind power that we have in the evening at night, and they could be charged up with that, and then they could discharge into the grid during the late morning and early morning hours, so to speak, like when dawn is happening, when wind might die down. and bridge that gap. And then the solar comes up, and now we've got enough electricity in the grid. But maybe we don't because it's a cloudy day. Well, now we've got cars there, and we can continue balancing even during bad weather. So it's a really impressive effort, and we're designing it into one of our apartment complexes now here in California to help it be nearly off-grid in an area that sees a lot of fires and therefore a lot of shutoffs of the electrical grids, and to prevent fires from high windstorms knocking down wires. So Utrecht, they're really doing something right there. And this is a technology available all over the world. So one of the bridges of that is schools, it turns out. It's one of the first places where this technology of charging back into the grid is being used. So first, just to note that according to the Global Child Nutrition Foundation, school kitchens in Malaysia typically have gas stoves, which are bad for people who are cooking over gas stoves because it is worse than the pollution that comes out of the exhaust of a car. Car exhaust goes through a catalytic converter. So all these nice ladies working back there are working over more pollution than comes out of a tailpipe of a car while it's idling there. And then below, you can see higher education campuses are expanding access to these electric scooter and bike and motorcycle sharing programs as a way of affordable way of getting their students to school from perhaps more remote areas where they can afford to live. And then you're seeing schools also really leaning in and putting solar and batteries up and working with buses, bi-directional buses, that can then make the schools into off-grid resiliency centers. So if there's a power outage because of an earthquake or a wildfire or a hurricane or a tornado, we're seeing this all over the United States, where schools are now starting to set up as places where they can offer electricity both back into the buildings and into the grid. Oh, this is an example of a school that electrified its kitchen here in Malaysia. This is they have 6 induction walks. Well, they have 7 induction walks, 1 induction griddle, 4 induction burners, so to speak. Got a deep fryer, all electric. Here's an example of some buses here in the United States. The one on the left-hand side is, they're making money essentially by offering their batteries from the bus into the grid. And on the lower right-hand side, this is another example of they're offering it for money. Because keep in mind, the buses are parked about 22 hours out of the 24 hours each day. So there's a lot of time during the day in which they can make money for the school and help pay back the expense of the bus even, because it's such a powerful battery for contributing energy. And city buses could be doing the same thing. So here you have, back in 2017, the first super quick charge electric bus was installed in Malaysia, and the Putra Nido EV bus project. And they had 11 of these super quick charge buses. So, the bus can charge up and keep on rolling. The batteries, they say, can last up to 10 years with proper care. And lithium-ion batteries can last 20 years with proper care. So it depends upon how they get used and how fast they get charged. And that's the thing about fast charging, is that the faster you charge, the more it degrades a battery. What you do when you fast charge is you heat up the chemicals that are in the battery, and the more heat that's in that process, the more it degrades the battery's long-term strength. So I point out that these superchargers are great for various reasons, but they're not good for keeping a battery healthy. It'd be better if they parked them and charged them overnight if they could. But nonetheless, the goal is to keep the bus out on the road, serving people, so fast charging. Here you see that Malaysia's first autonomous electric bus trial is coming soon. I can tell you, as a Californian, this is quite a topic, as we see all over San Francisco autonomous cab drivers, or lack of drivers, and people getting into Waymos and such, and having autonomous cars take them around in San Francisco area. So Sunway BRT was the world's first, think about the world's first all-electric bus rapid transit system in 2015. It was using electric buses. So now, since they run on a sort of a closed circuit, not going very far, so they say, yeah, this is actually a pretty good place to put in an autonomous bus. And they said that we're still going to evaluate it from a technological, social, and economic standpoint. Not going to just throw us into the wolves, but here are examples where there are captains to the boats. So, as Malaysia starts electrifying all of the boats that are being used with this significant amount of coastline. So this is one example here, is the Antonia van Kamp, and there are a lot of electric ferries. This is just one of them. So this solar electric ferry, which has solar on the roof to help out, so it's charging somewhat as it's going along. It connects an island in the Baltic Sea to the German mainland. It carries 20 people and 15 bicycles several times a day, back and forth. Down here, you see the electric ecotourism in Vietnam, and this is something it's important to think about. If you don't like the sound of highway noise, or construction noise, or industry noise, all those things get quieter when you make it electric. So here you have these nearly silent boats. They go on excursions into the jungle, into the forest, and they're trying to see rare animals without scaring them off. And because the boat doesn't have any kind of loud engine noise, you can just slowly cruise on up and see things undisturbed. Here you can see an urban application of that. So this is another one of these solar-powered ferries. And here you can see them beating traffic with an electric ferry in Bangkok. So they've got solar panels on the roof to power the lights, other onboard loads. Thailand, they got their first electric commuter ferry in 2018. And then in 2021, they added 12 more. This is a good idea. I was going to talk a little bit about solar, getting close to the close of my presentation here. So Malaysia's #1 home solar installer is doing more than just installing residential solar. I thought this was really impressive. I want to share it. Maybe some of you are familiar with this, but on the left-hand side, you can see them installing just a standard solar array in a Malaysian house. On the right-hand side, you can see them in a very rural area, rural village. And the United States still has 1% of people living in the country with no electricity. Some of them are people who live near to me, actually, because I live in a mountainous part of California, and there's a fair amount of that. So to expand on this, you can see that they get these, what's called a Pico solar array from Sols. And this doesn't just come as like a solar panel, but it also includes solar training. So on the left-hand side, you can see this is fantastic. Just this light bulb here, they're running on a panel, and it is equivalent to running a generator for 720 hours. So 2 hours, powering a light bulb with a generator for 2 hours costs the same as running a light bulb on grid for 720 hours. The point being that the generator is crazy expensive, and the solar panel is nearly free these days. I mean, it still costs some money, but my gosh, prices for solar panels have dropped more than 82% in the last 10 years. And if you look at it past the last 15 years, it gets closer to 90-something%. So it is currently globally the least expensive, both utility scale solar and home scale solar are both the least expensive form of electricity that you can purchase. So over on the right-hand side, just giving credit where it's due. They educate new solar installers and recruiting people into this growing industry, both at the utility scale and the home scale. But home scale is very popular in Malaysia. So students from low-income families are offered free education and room and board. And I feel like that's an excellent thing. If you're putting some solar on your house or your business, and you're thinking that you're also contributing to people in society getting a better chance at employment and education. And they're not the only business. I just want to call out other folks doing good work there. So Evergreen Solar Engineering develops solar plants in rural communities and hires local folks also. With these two examples, Anjam and Maja, there are two such hires, and have initially just learned on the job while helping their village gain electricity, but they eventually became permanent staff. And this is what we see in the United States. There's a lot of effort to try to address colorism or racism in the United States, which has been historically horrifying, and there's still significant problems to this day. And so it's exciting to see in California, where I'm a real expert on California, seeing lots of different solar installers do that affirmative recruiting, trying to reach out, different government programs helping set-asides if you're a small minority business and you're building zero net energy, affordable housing even. So good stuff there. Here's an example down in Australia. This is off-grid groceries, South Australian produce market, SAPM. They are making grocery stores that have solar arrays and batteries so they can run them off-grid at times, or they're running as grid service, but really impressive. And Malaysia also has microgrids already set up, like this one on Banji Island. And so that is the conclusion of my presentation. And thank you all for your attention. I'm going to stick around, of course, for questions. You take care. And Serina, back to you.
Yeah, thank you very much, Sean, for that. Sorry, I'm just sort of catching up with the questions on the side there. So let us continue with the program, and I would like to introduce our two panelists that's joining us. But first, I will introduce you to Gregors, who will be giving a presentation. Supporting the electrification both ways, or biodirectional in emerging electrification of transportation mode, by Sean just now, which, as we all know, Malaysia government is in the latest budget supporting this transition to EV mobility from microsystems to buses. We now bring you electrification of buildings with a presentation from Gregors, Managing Director of IEN Consultants, a pioneering high-performance building design consultancy operating in Malaysia since 2000, and specializes in building designs that are highly energy efficient, good daylight harvesting, healthy, and connects with nature for people to thrive. His key projects include zero energy building and pioneers in the field of buildings as batteries. After which we will have Dr. Stellios NEAPOLI, a CEO of NEAPOLI, a foremost expert on sustainable environmental design and engineering, emphasizing the built environment's impact on health, society, and climate, has co-authored China's first sustainable design guide, now a textbook at Tongji University. He has consulted on over 100 plus projects across Asia, Oceania, Europe, including Crystal Palace Park, Doha Airport, and the controversial NEOM line. So first, I'd like to call on Gregors to give us a presentation on electrified buildings. Thank you.
Thank you very much, Serina, for that introduction. Let me share my slides. So this is me riding around in Beijing on an electric bicycle, but I'm actually based here in Kuala Lumpur, Malaysia. So I would like to maybe bring it up a level in a way and talk about the electrification of everything, because this is the way it's going. And the reason why it is that not only is it possible, it can actually be done within 15 years. It will also really improve energy efficiency by about 50%, because a lot of the fossil fuels that we burn are not used very efficiently, whereas electric energy is much more efficient. And interesting as well, it's the cheapest way forward if we count all the costs. And on the right here, you can just see a magazine cover from The Economist that already about 5 years ago said that the combustion engine, I mean the car engine that we know, is a roadkill. I mean it's over. So on this 15-year transition to 100% renewable energy, this group of energy transition experts made this joint declaration a couple of years back. There's a link here where you can see their video on this, and they also have a website. They did this based on some very detailed studies. So actually, there's a study where they looked at 144 countries around the world. They took the weather data for each of these countries and did these kind of 3-year simulations. And then they simulated with different kind of technologies, various renewables, and various energy storage systems, how we can how the production of renewables can match the consumption with some smart controls and with some energy storage. So the idea is that throughout these 3-year periods, you would never run out of energy storage. As you can see, the green line there, there's one space here where we get close to 0, but the rest of the time we actually have plenty of buffer. So this is very complex. But basically what they found was that if you count all the cost, then it's also much cheaper to do. So if we only look at the energy costs, and in the table here on the bottom right, and this is US cents per kilowatt hour of electricity. So if you only look at the energy, actually the energy cost is already cheaper. But once you factor in the externalities, so all the effects that fossil fuel use has on health, so air pollution and climate change, this actually comes at a huge cost, which doesn't apply if you have 100% renewable energy world. And therefore, it's much cheaper to electrify and get away from fossil fuels. So if we have all these renewables, of course, the energy production will fluctuate much more. And this is where buildings will actually play an important role, because we can and should design buildings to be much more flexible in the way they use energy. So when there's an excess of energy, where energy is cheap, they can store energy, both maybe electrically, like parked cars in electric cars, but also thermally, so overcool certain things. And when there's less energy available, then they can shut off certain systems. So a very interesting report was just published by the International Energy Agency, and you can download it here, about energy efficient grid interactive buildings. So one of the key charts in this report is shown here. So basically we push for energy efficiency, of course, and once we put on all these renewables, let's say solar in this part of the world, we will have an excess of production during the daytime hours, because that's when the sun is out. So storing this energy means that we can level it out, as the red curve shows here. And then the report is full of examples of what are the kinds of technologies we need to use, and the kind of metering, not just smart meters, but intelligent meters. So meters that can basically communicate to the building when to shut certain systems. Yeah, so I can highly recommend that you read this report. In this chart, they just show that this flexibility in the grid, buildings will deliver about half of that flexibility moving forward. So that's quite interesting for us in the building sector. And here they mention all the different categories of things that you have to do. I won't go into details on this. You can study these slides on your own, and some more details on this, but a little bit too detailed for this presentation. So just to finish off, I'll just show a building as a battery project that we're doing in Malaysia. It's about to complete. It will be in December of this year. So this is a university building. It has a lot of solar. Even this signboard here is a solar panel. And it produces twice as much energy as it consumes. And it has various storage systems, a bit like the IEA report. So we have a battery, but we also have a thermal storage system. And we also cool down parts of the building structure. So we can store electricity in thermally, for example, in some big tanks like here, when the energy is available. And then we sort of simulate hour by hour, see how the energy flow is going, when should we start charging certain systems, when should we shift certain loads, and so on. So it's quite an interesting and new way of thinking about energy, that you always have to respond to the grid and what's most optimal, because the grid in the future will have dynamic rates. So in the daytime, the energy will probably be much cheaper. So if you can store that energy and then sell it back to the grid later in the day, it can also be a money-making strategy, as Sean said, with the school buses, for example, that can sell electricity back. So this is the breakdown from this building, so just to show that this is on the way here in Malaysia as well. So thank you very much.
Thank you, Greg, as you're ahead of time, actually. I was very curious to see the other two diagrams you presented earlier, and maybe you could just walk us through that in just sort of 5 minutes. The previous overall diagrams that you had, explanation about the electrification from energy efficiency onwards, before we segue into the panelist session, which we have a good half an hour panelist session. I think you had earlier slides, perhaps, yeah.
Which one was that?
Yeah, just one more back.
This one?
Yes, just a little bit of an explanation about the categories and enablers here, yeah.
Yes, yeah, definitely. So basically, if we start with we can start from the top. So basically, energy efficiency is a really good idea and also has a good payback time. And actually, Malaysia has just passed the Act on energy efficiency and conservation, or bill at least, that will become the Act. So this Malaysia is moving forward in this. Then, of course, renewable energy, the purple one, and on-site storage. So this is what I talked a little bit about. It's not really being done at the moment. But this is where, for example, we have buildings we've done where we embed some pipes in the concrete slab. So we actually can cool down the whole structure of the building. So when there's plenty of energy, we can cool this huge concrete mass down to about 20 or 21 degrees. And then, let's say at night when it rains or whatever, and there's less electricity available on the grid, this cooling is still contained in the mass of the building and is released passively to the building. Then we get to smartness. So this is the Internet of Things. I mean, basically, you have all this renewable energy available. You have different prices on the grid in the future. It's not the reality yet in Malaysia. But how does the building know what to do, right? So that's why we need this kind of much more smart appliances and building systems that can take this information and act on it automatically. And this also relates to the two-way communication down in the green here. So equipment level, it could be your fridge, for example. Let's say the electricity price becomes really high. Then the fridge can switch off for a couple of hours because it's okay, the food won't spoil, right? And then it helps you to save electricity, because once the electricity price drops again, after that peak, it can keep cooling and using cheaper electricity and helping out the grid. So the same kind of level can be done on a building level. And then on the advanced metering, at the moment, I think in Malaysia we have these smart meters, right? So the bill is just sent to TNB. But if we had really truly advanced meters that could also act on the current electricity price, or TNB could say, oh, we want you, we have a bit of trouble meeting the demand, please switch off certain systems or turn up the thermostat half a degree, right? So instead of having an office at 23 degrees, it's 23.5 degrees. You can save a bit of energy. So this kind of communication is coming. And this has, also to do with the load and frequency management at the bottom. So of course, with electric vehicles, again, when should they be charging?
Today
When
I'm going to buy you guys
helping,
lunch, okay?
helping the
From
grid?
Kusa. I will order it in.
Sorry, someone's phone is on.
But they
Sarah,
are very, very good.
Sarah, is your phone on? Speaker on?
Yeah, I've muted her. Don't worry.
All right.
Thank
Okay,
you.
great. Yeah. So yeah, so there are various standards for this. It's also listed in that IEA report. What standards to follow. There are some different standards in different countries, so it's a little bit messy at the moment. But I think this is something we should all be incorporating in our whenever we design any buildings or any systems that use energy. So just keep in mind it has to be interactive with the grid.
Thank you, Gregors.
Welcome.
I would like to introduce all the panelists here, especially bringing in our Dr. Stellios NEAPOLI. So
Hello,
Sean, if you'd like to join us. Yes, so as mentioned before, Dr. Stellios NEAPOLI is the CEO of NEAPOLI and is one of the foremost experts on sustainable environmental design and engineering, emphasizing on the built environment's impact on health. So I think we have a very good set of panelists with us, and with Sean to discuss with regards to 100% electrification. And I see there's some questions that have come in from the participants. And so we'll take those questions first to the panel. The first question to Sean is, fast charging DC systems require substantial power supply, more so if there are multiple chargers in one spot. It seems unbelievable to get solar PV systems to provide the desired power capacity and energy. Can you confirm that PV-based charging is a real option, and how much space the PV system would take?
Yes, I can confirm that. I have an example of that. The highest power load in a house is your stove. That's the thing that can use the most power, an electric stove. So in the United States, we're trying to do the same thing that you're seeing with those EV chargers, which is provide essentially fast cooking with a 4-burner induction range and a big oven underneath it. And what's happening is underneath the oven is there's a battery, a 4 kilowatt-hour battery. You can think of it as the equivalent of what you're seeing there with that EV charger. The battery gets charged from the grid, but only a little bit, 1,800 watts. It can produce 10,000 watts. That's because the battery inside is set up to be able to push out a huge amount of energy. So the stove just cooks as much as it wants. As the battery gets discharged, it trickle charges, but the battery is there to provide the fast charging, so to speak, for the stove. Okay, so similarly on the highway, if you have the battery sized right, you'll be able to provide that much fast charging. And if you have both the solar array and the available grid charge, if you size them right, then yeah, they're both producing power, and you could be charging into that battery. So yeah, technically can be done, and there are equivalents to what I was showing you in Malaysia that are here in the United States. There's a bunch of businesses that offer these relatively fast charging. And when I say fast, I charge at home with 1.8 kilowatt, and fast chargers on the side of the highway are usually 50 kilowatt, unless they are ultra fast, and then they're 100 kilowatt to 350 kilowatt, and they're all fast. But here at home it's 1.8 kilowatt and it's slow. But it's more than what I need, actually. I don't even use my house's capacity nearly as much as I could. I hope that answers your question, that yes, it's real and it's technically feasible, and people are doing it not just in Malaysia but all over the world for like how to install car chargers on the sides of the highways.
So I think there's a very big burning question with regards to the ecotoxicity and problems associated with batteries. So the next question from a participant was, beyond carbon, I would appreciate your input on alternatives or examples to mitigate and handle the full scope of environmental impacts around a battery's LCA. And I think one of the slides that Gregors had shown earlier was that, there's no impact, everything is positive, but perhaps one of the negative components of it is we haven't talked about solar disposal panels, but the other one is batteries. So maybe Sean, you'd like to take that question, or Gregors, or even Napoli?
Can we share? But I very much want to quickly respond on the amount of mining, that one part of that life cycle analysis, the beginning, the amount of mining that is used in a fossil fuel economy, coal mining, oil drilling. There's more than 500 times as much soil disturbance and mining that's done for that economy, because batteries, yes, you have to mine, but then you reuse it hundreds, thousands, tens of thousands of cycles of time. So it's there's just a big analysis came out and said 530 times as much mining goes into our current fossil fuel economy than our battery economy that we're moving towards. That's why I want to chip in there.
Dr. Stellios, you were about to say something.
Yeah, I would like to comment about the battery. Of course, is a very important concern, a very serious concern, and a lot of effort is lately put on how the end life of batteries, how to improve the end life of batteries, and how these batteries can be recycled. But also a lot of effort lately is put on how to repurpose the batteries. Batteries from electric vehicles can be used for other purposes, perhaps with that can accommodate a different use, not perhaps the full capacity that the batteries have lost, but can be used effectively for home use, for storage of energy at home, and that gives a new path. There are new technologies also coming up on batteries. There's a lithium sulfide that reduces the toxicity of materials and the raw material use, but also there is also discussion about replacing chemicals like lithium with graphene. A few years ago, there was a very big discussion. This research has slowed down in the past 5 years, but there is a big potential for using supercapacitors, at least for home storage, to replace lithium batteries.
Okay.
I can maybe
Yes,
add
okay.
to that as well. I'm not a battery expert, but I agree with all these statements. And also there's actually a huge potential for pumped energy storage. So instead of storing excess energy in a big battery bank, you can sort of reverse your hydropower station and pump water up in a high-lying dam. And this has very little environmental impact, especially if this dam exists already. But there is actually, if you want to establish new pumped storage, there's, I think, almost 500 times more pumped storage around the world and fairly evenly spread out throughout the world than we need for storing energy for the grid.
Thank you, Gregors. And to Sean, considering the two-way charging and feedback to the grid, what portion of energy capacity can be sent to the grid before the battery capacity needs to be retained for travel back to the home? In Malaysia, we don't have TOU electricity tariffs to profit from resale of energy to grid at the moment. This is coming from the participant who gave the first question, which is IR Raslan, which quite a few of you know on the panelist group here.
Okay, so but the first part of the question was, I apologize.
Considering the two-way charging and feedback to the grid, what portion of energy capacity can be sent to the grid before the battery capacity needs to be retained for travel back to the home?
Got it. Okay, so they've studied this in a whole bunch of different field studies, and what people want is 80 miles of range, or in kilometers. Can someone do that for me real quick? That must be like 100 kilometers, 120?
120.
Thank you. Okay, so they want about 120 kilometers of range left in their vehicle, so they can go a long distance, so they can go to some other charger. In electricity, that's about 23, 25 kilowatt hours. And most cars are being sold today are in the 60 to 80 kilowatt hour range. They're averaging about 74 kilowatt hours in the United States. So people are saying, basically, I'd like to have 1/3 of my battery left, but I would be willing to sell 50 kilowatt hours, which is a lot. A Tesla Powerwall, that's 13 kilowatt hours. So it means that you have, in an average car, maybe 4 Tesla Powerwalls worth of electricity that people would be happy to sell back in. Just leave them enough to go get charged up or drive someplace the next day. So the answer is that in California, there's 80 times as much battery capacity on wheels as there are on people's houses. And there's 3 times as much battery capacity on wheels as there is batteries for the utilities that they've installed. So by far, the most battery we have in California is car batteries. And we're starting to see like our utilities incentivizing bi-directional chargers and rolling out programs to take advantage of that battery to balance our grid.
Thank you. That was a great answer. There are sadly been some reports on fires with EVs in Malaysia recently. Any comments on this issue from the panelists, Dr. Stellios?
Yeah, safety, of course, is a great concern. I don't have much to comment about this. I'm not an expert in EV safety, but I do agree that we have to consider this, especially when we plan the parking. As we know, Serina is working on the design of buildings. It is very important that we take this into consideration when we plan for the electric vehicle allocation at car parks, to have them at locations that take into consideration this additional risk.
Well, the latest bomber release is that electric vehicles should be parked in certain positions and should be compartmentalized. So yeah, that has just come up this year, actually, due to some fire concerns that happened in China. I'm not quite sure I've heard any of the fires so much in Malaysia, but you're right. There are still some concerns there.
Well, can I offer?
Yeah.
In the United States, I'm seeing the battery chemistry of vehicles changing. So Tesla, Chevrolet, Ford, they've been moving from more flammable to less flammable battery chemistries. And I think that's also true for stationary batteries, going from lithium ion to lithium iron phosphate, for instance, which is much less likely to catch on fire if it gets hot. So some of the practices, like putting up carports so people can park their cars in the shade, that's good for batteries. Slow charging them as opposed to super fast charging them, that's safer for batteries. It's not as hot. I think that as battery chemistries convert to safer battery chemistries, as the whole industry matures, these are all known problems. And I think as Dr. Plainiotis was saying,
Stellios.
Yes, you're saying, we have to plan for this, but that doesn't mean we shouldn't start planning for it. Like, we could move forward with electric vehicles. They are getting better and safer, etc. So let's just, plan for it.
There was a mention about dynamic tariff. Do we know anything of when dynamic tariff will come into play in Malaysia that will support this bidirectional or charging that we're having? Do you have that in California, dynamic tariff, Sean?
We do, and I've studied it a lot to object to it. Essentially, what California's utilities have told the public, not with any science to say it, is that people would be educated by paying more money at different hours, but then their own science showed that only 1 in 8 people were willing to be educated, and the other 7 weren't. And the people, that 1 in 8, they're mostly low-income people who really needed it. But unfortunately, from all of our studies of low-income households, is that they can't control much more than they already have. They're already working at the least that they can, sometimes not even as much as they want, just the least that they can. And so time of use rates, these flexible rates, they end up charging people who can't control their behavior as if they were going to get educated out of a new higher bill. And then people who can afford it don't care. So I've been less excited about these variable rates, considering I work just on low-income housing, people who have less money. And so when I study what happens to them, I don't support it. I think that Malaysia should stick with the rates that you have, and we could work around that better than a time of use rate.
Okay. Hi, Gregors. Does having solar panels on the roof heats the room underneath since they give off radiated heat? Do they also trap the heat from below?
Yeah, I mean, solar panels absorb almost 100% of the solar energy. So I'm becoming less and less enthusiastic of a huge rollout of solar panels in Malaysian cities, where it's already quite hot, and it can actually all these solar panels can act as a urban heat island effect for the city, maybe increase the temperature by 1 or 2 degrees. So I think solar panels are great, but maybe we also have to be aware that they can cause this urban heat island effect, and that's critical for cities in Malaysia where we live right on the border of having to switch on the aircon all the time. So yeah, I think there's a real issue there. On the local sense, I mean, if you put a solar panel on your roof, it will probably make your house feel a bit cooler because the heat is now deposited on the panel itself, and therefore it doesn't get to your roof tiles or whatever your roof you have. So it will take the direct solar roof load off your roof, but it will help to heat up the urban environment in general.
Well, Sean actually showed in his first slide solar panels on the facade. It's something that's not practiced here just yet. And maybe responding to that same question, putting solar panel in a more temperate climate on the facade versus being that on a building facade in the tropics. Because the question was solar panels and heat.
Go ahead.
Can I add on this? Another technology that is, I think, underestimated in Malaysia, unexploited, is the solar thermal technology. Although there is demand for hot water, for heating water, for hotels, and for residential buildings, we don't see equivalent adoption of solar thermal. Solar thermal panels are the perfect solution for urban heat island because they absorb 80% of the solar radiation, and instead of neither reflecting it to the neighbor or storing it, they store it as a thermal energy in the tank and make the best use of it. And we have an example of a vertical, almost facade installation, 90% vertical installation of solar thermal panels at the Kuala Lumpur International Airport for the hotel there, and it worked very well. Although we have 50% efficiency compared to the roof mounted. It's a technology that is very low cost. It doesn't use primary toxic for the environment raw materials. It uses only aluminum and insulation and copper pipe, and it can be produced locally in Malaysia at very low cost. And I would like to see more adoption in Malaysia of this very simple and good technology. Also, storage is just a tank, insulated tank, as opposed to the chemical solutions that we discussed now.
And Sean.
Well, I had not heard of the analysis that said that solar panels would contribute to the heat island, but I can understand how that could work as like black devices as opposed to a white roof. The designs that I see people moving towards is using white roofs underneath solar panels and using the solar panels that don't have stickiness on the back of them. They don't have the white what's it called? Melamine, a white melamine plastic layer. Anyway, they're called bifacial solar panels, so they can get sunlight that's bounced below back through them. And it can increase their efficiency to like 30% efficient. The question of what happens that other 70%, I can see that radiating a fair amount of heat. But at the same time, right now we have this problem of people needing to do air conditioning during the summer. And when we're putting solar panels up on the roof, we're making far more electricity that's available for air conditioning and all the other loads than we are making heat, at least not in the building. So I'm like, that one's, I'm thinking about that one. Now, on the topic of vertical solar panels, I think that, we see 50 to 60% efficiency compared to putting them up on the roof. But at the same time, when we're doing low-income housing, it's such a powerful way of lowering utility bills, which figures into the financing of affordable housing. It's so effective that we're putting solar panels on the walls because that is a less expensive way to build and own the building in the next 10 years. There's a pretty quick payback. So it's just a practical solution to building more housing for people with less money. Just putting more solar panels on it.
All right, I'll keep to the solar panel question before I revert back to another set of questions that's from the floor. Usually the ROI for solar panel PVs is 3 to 5 years. Are there any quick wins that owners can do to start electrifying their household billings, for example? I think Dr. Stellios and Gregors, you probably know what those solutions are. The EEs in households, and I'm sure Sean does. So Sean, would you like to take that question? I'm not sure the payback time in California compared to Malaysia, but perhaps give us some highlights there.
So payback, I think that Gregors had a good point that one of the things that needs to be valued is people's health. So the fastest payback would be getting rid of the gas stoves, and because the health impacts are the same as having someone who smokes cigarettes in the house. And so it's like a pack or two of cigarettes a day is the same amount of smoke that comes off of cooking. It's a very dirty burn. There's no catalytic converter. There's no scrubbers in it. It's just a dirty burn of gas. And the fact that you can't smell it doesn't mean it isn't there. The fact that you can't see it doesn't mean it isn't there. It's still the nitrous oxides, the SOx, the benzene, the formaldehyde. So I would say quickly getting an induction range, one that you can just plug into the wall, would have a fast payback for anyone who has asthma, anyone who's has heart attack medications they need to take, anyone with any kind of cardiopulmonary illness has a significant decrease in the amount of medication, symptoms, hospital visits, if they get rid of their gas stove. So yeah, but solar is really obvious on the utility bills, very fast payback. The other one would be for the water heater. If you're using electric resistance water heating, which is very common in Malaysia, converting over to a heat pump, which uses 1/3 to 1/4 as much electricity the next time that your water heater breaks. I'm not saying do it right away, but when you're ready, that would be another one that the increase in construction cost of getting the heat pump would be quickly paid back by using 1/3 or 1/4 as much electricity.
And that heat pump would give the waste product of that heat pump is cool air. So then you get free air conditioning.
Yeah, it's nice. You put one in your like next to your kitchen and get a little free air conditioning in the house.
Nobody mentioned the air conditioners that people actually have. Funny enough, if you do see some of the low-cost housing or the B40, what sticks out from the wall is either the antennas or the air conditioning units here in Malaysia. So I think the other area is basically transitioning to more energy efficient air conditioners. as we use a lot of that here.
Yeah, on that note, Serina, I took part in the Global Cooling Prize, which was a competition, worldwide competition to produce a split aircon that was 5 times more efficient. And these products are being commercialized now and should be coming out hopefully next year. So basically, air conditioners that have a 4 or 5 times lower energy consumption than the best air conditioners on the market at the moment. So watch out for that. It's coming, because current air conditioners only have an energy efficiency. Even the inverter ones that are the most efficient, they only have a thermal efficiency of about 14%. So they're actually highly inefficient.
I define efficiency in the coefficient of performance. And I'm not saying that how you're defining is not the correct way, but in the way that I'm familiar with it, I would say a coefficient performance of like burning gas is a 0.9, or electricity, just straight electric resistance is 0.9 or so in its efficiency. And an air conditioner that's good should have a COP, a coefficient of performance of 3. And the really good ones have COPs of 4.5 and 5, 6, even 7 I've seen in Japan. Like the very, very best ones that Mitsubishi makes that are real small, 7,000 BTU ones. So I just want to reinforce that there's a lot of room for growth in air conditioners, particularly adding computers and then moving to the newer refrigerants, which are right now R32 and potentially propane. That it would help Malaysia's grid in the summertime if you guys had higher standards, just like everyone's grid. If we had higher standards for air conditioning.
So there's a question to all 3 of you. What advice would you give to government decision makers in Malaysia who need to rationalize Malaysia's energy subsidies? Are there examples globally or subsidy transition mechanisms that prevent gaps and address energy poverty while at the same time not unfairly benefiting already wealthy investors? Thank you in advance. And should we begin small piloting programs with neighborhoods and communities? So this is a hard one.
Well, okay, so on energy poverty, that's my thing. I work on affordable housing. And what we've seen is that electrifying end loads like space heating, which you guys don't have to think about. How about water heating, going from a gas water heater to electric, or a stove, gas stove to electric? None of those things save money particularly, maybe a little bit. But if you're going to address energy poverty, it means putting some amount of solar on the roof. And I showed in my presentation, the example of an urban solar array versus a little tiny one for a rural village. But any amount of solar is far more valuable than almost any energy efficiency measure other than going from incandescent bulbs to LED bulbs. But in terms of what it does financially, solar is a savior other than light bulbs. So, and one could argue some other measures. I don't really want to get into that, but just generally so, I would say that if the government of Malaysia was encouraging a small amount of solar on everyone's roof, that would solve a lot of problems. Not so much that it backfeeds into the grid and creates large problems, just a small amount that everyone got so they could handle air conditioning and the refrigerator during the summertime. Just keeping your food going and not dying if there's a heat wave. That kind of thing. That's what we've learned. And there's programs like that in California that are completely funding for free solar arrays on low-income housing, just to try to address this energy poverty issue. Because California, while you might think it's rich, it's actually the poorest state in the United States. It has the largest number of poor people and the highest percentage of poor people. It's truly a bad state when it comes to energy poverty. So that's my thought, is trying to widely distribute at least a little bit of solar for every house.
Well, we have 365 days of summer in Malaysia. One of the beauties that we have sunlight mostly from 7 to 7, and that's also a great benefit in a lot of ways. But yes, I think this energy transition has been done quite slowly, even within our own households, but we should start now. There is a question on by somebody on Sean, your slide on eco-green solar engineering develops solar plants in rural communities. Actually, those technicians in the photo are my company. Oh, yes, somebody is doing a bit of Gabungan Binaan Juru Tenaga staff doing T&C at one of our sites. So yeah, he's extremely happy that you put that one up.
Put it back up just for not busting me for saying something wrong.
No. He was saying thank you. I think that's what it was. Somebody's
Absolutely.
put up also, yes, this one. Somebody's also put from the Penang Institute something on carbon pricing to support sustainable development in Malaysia. I'm not quite sure what that is in relation.
That was from me, Serina.
Okay. All
yeah,
right.
because you were asking what can we do without hurting the low income groups in Malaysia, and actually this study is done by a think tank in Malaysia, in Penang, Malaysia, on carbon pricing for Malaysia, where 40% of the carbon tax that's collected is actually circled back to the B40, the lowest income earners of Malaysia. So actually they don't suffer economically from the rising energy prices thanks to this environmental tax. So it's actually a very detailed study. I think Malaysia needs to go in this direction. It could be a political win because the B40 will benefit from this economically. But at the moment, of course, there's huge subsidies. I think about 40 billion ringgit was paid last year in Malaysia to make electricity artificially cheap, and energy artificially cheap. So it's we're sort of doing the opposite at the moment.
I was to say, like, I think that, you know, subsidizing energy is generally a good idea from a political perspective. There's riots when people are, you know, without energy. However, I think that subsidizing energy so that people own it with a small solar array up on the roof is a better strategy for actually creating durable wealth. Because the energy that the grid is usually using, you know, Malaysia is about 89%, well, 81%, I think it was, burning stuff. One thing or another is getting burnt to produce electricity, and then it's gone. If you put a solar array up on the roof, even a small one, you own that electricity for 20 to 30 years. It's going to be just that good as it is today for at least 20 to 30 years. So that's an entirely different way of subsidizing energy in a way that I think creates durable wealth, as opposed to just burning it up into the air.
Thank you for that. Stellios, there's a big thank you from Gary Thesaurus, who's in CGM. Thank you, Dr. Stellios, for supporting low-tech, low-cost solar thermal. If solar PV is not economically feasible, should banks consider packaging financing that combines solar thermal with rainwater harvesting? We do have a banker on the line as well listening in on this, so CIMB, so I hope he takes note. But there's a question to you, Stellios. Could we actually combine solar thermal with rainwater harvesting?
Yes, certainly. And we can combine solar thermal with photovoltaics, because we know that there is a certain demand that we can capture with the solar thermal, which is around 10% for residential. So we can't reach the extent of PV. Combining with rainwater, yes, with rainwater harvesting, because they are both low-tech solutions, and perhaps there are more. They both require more plumbing capacity know-how than electrical. So combining these two together, we can have installation that can be done by the same teams.
Thank you, Dr. Stellios. Another question here on any advice about using home solar installations to charge EVs in Malaysia. Just on that note, I tried to get a cost on putting solar PV on my mini terrace house, and the cost of the battery was more expensive than the solar. I mean, because we would probably only use aircon at night and only one space, but the cost of battery to do that, to use it at night, was more expensive than the cost of the solar panels itself. But anyway, the question here is using home solar installations to charge EVs in Malaysia. Where do we see that happening? Is it already happening?
Well, there's two ways of doing home EV. And just, there's about 75% of the people who can sign up for home solar, home solar, but 75% of those people of the capacity is taken up. So Malaysia has a problem right now where there's seemingly going to be more demand than supply of people who are legally able to hook up PV to their homes. However, there are multiple products in the world, this being one of them, where you can take a small amount of solar just for the self-consumption of the house, and it comes with a little controller to make sure it doesn't backfeed into the grid. And then you can plug in a small solar array that you don't have to ask for permission. And it's also small enough that it's not expensive. This is a few $100s as opposed to thousands of dollars. And then there's that other strategy where you put one car in the United States, you'd have about 1.5 to 2 kilowatts of panels up on the roof. So just driving a car, to your answer, is a fair amount of electricity if you drive it like an American does. I'm not sure how far you personally drive, though. Americans. So 1 to 2 kilowatts, I think, is what you need on the roof for offsetting your car.
Okay. I'm not sure whether we had already covered examples globally for subsidy transition mechanisms to prevent gaps and address energy poverty. Did we cover this already? Are there any good examples of this in neighborhoods and communities, Sean, from your experience?
Well, I mentioned earlier that I think that the most effective way of addressing energy poverty is some amount of solar in terms of just the amount of energy savings, utility bill savings compared to what it costs to get those savings. So that, and then the second one is enabling bidirectional chargers, because when you put up a 5 kilowatt solar array up on the roof, what that means is that when the sun is at its most intense, it can produce 5 kilowatts of power. Your car chargers that are bidirectional produce 10 kilowatts of power, which is only the equivalent of driving 15 to 20 miles an hour. Someone else has to convert that into kilometers an hour. It's probably like 25 to 30 kilometers an hour. So the point is that the car does not get stressed much to put out more than twice as much electricity in the moment as the best that the solar array can do. So today, I would say the cheapest thing you can do is put up a solar array. But if you were to also deploy widely bidirectional chargers so that people can contribute a little bit of electricity when it's valuable, if there's time of use, or they can run their house off grid if there's a power outage, or just run their house in the evening without using the grid at all. So you just don't have to use any electricity, tiered or time of use. You just don't have to use it. I think that's probably the second most powerful, widespread option that would put power in the hands of people, literally, to make some money or avoid costs.
Sean, you mentioned something on 1+1 solar sources that limit to adoption of this program. Are there any limits to this? Are there such programs for the B40 housing or middle income housing, community solar or microgrids? This was a sort of key question about creating microgrids and community solar installations impacted energy reliability and sustainability in remote areas of Malaysia, and what are the key considerations for communities looking to implement such solutions?
Okay, that feels like a big question. Okay, so, well, let me go to this example here. So this microgrid, and what is a microgrid, first of all? microgrids usually are connected to the grid, the bigger grid, but sometimes they're not, and they're off grid, and they use the same word. So this hybrid microgrid, and hybrid, I think in this case they're describing is because it uses a diesel generator. It's not just renewably powered, but this is an example where it's providing electricity to 7 different remote villages. So we have examples of this just like 7 miles from where I live right now. An indigenous community called the Blue Lake Rancheria. They have a huge microgrid. It is powered up when there's an earthquake around here. So it's our resiliency for emergencies, but mostly they use it to run their casino without having to pay for electricity. Very expensive to run. Each casino machine uses about as much electricity as one American house. So each one of those gaming machines is a big deal. So mostly they're running the microgrid to make money, and sometimes they're running the microgrid to save everyone's butts around here, because everyone goes to their reservation when the power's out in our community, and they rescue people, like people in wheelchairs and things like that need to have power if we have real emergencies around here. So this strategy of trying to get solar panels and cheap batteries, either thermal batteries like what Gregor was describing, where you make an efficient building and it doesn't use energy or it stores energy, but then also electric batteries, which I argue is cars, buses, trucks, heavy duty equipment that isn't needed to be plugged, like isn't need to be used at that moment. That I think is the batteries that everyone are buying. That's just how the world seems to actually be, is those are the batteries that people are purchasing. And I think that is going forward what it looks like to incorporate storage into our grid, is mostly figuring out how to use the cars and trucks and such, and then pairing it with solar and wind, mostly.
Well,
that's answer your big question.
Okay, we have another 3 or 4 minutes left, or 5 minutes, and I'd like to ask some closing remarks in terms of where do you see the future of electrification, Sean, and we'll do a round with Stellios and Gregor's as well, in terms of transitioning to this and adoption of this. On the last note, we have 30 million vehicles in Malaysia, or more than 30 million vehicles in Malaysia, from trucks to scooters to buses, and we have a population of 32 million. Actually, at last year, the amount of vehicles surpassed the amount of people. So any last words, Sean?
Very American of you to have that many vehicles and anyway. Okay, so your country is about the same in population as California, and what I'm seeing is that about 5 years ago, 2 to 3% of sales were electric vehicles, and this year it's about 30%. So a 10-fold growth in 5 years. I think what we're seeing is that the growth is happening exponentially, which human being brains don't work well with when things grow that fast. You know, you have a hard time realizing it's going to double next year, and what happens if it doubles the year after that, like how fast that is. But I think the point that was made earlier by Gregor is that actually it was the video at the very beginning. It's going to take 10 to 15 years. That's how every other revolution of technology, be it cars from horses or cell phones. Right now we're doing a lot of different technologies all at once. Stoves is one, cars are a different one. But the data shows that we are an exponential curve growth already since about 2018 for heat pumps, for electric vehicles, for buses, for all these things are going up much faster than just a straight line. They're going up at a bent curve. So I think we're going to see significant electrification in Malaysia in the next 7 to 10 years. We're just going to watch and look around and be like, wow, things keep on changing. Wow. That's my prediction.
Stellios, Dr. Stellios. You can unmute yourself.
Yes. Thanks, Serina. I believe there's a clear roadmap in Malaysia, although not as fast as other states or California or the EU, but there is a clear path and roadmap for electrification in Malaysia. We have the National Energy Transition Roadmap, which was unveiled recently in Malaysia, where the plan is to have 80% of the vehicles being EV by 2040, and 90% of the local production. As we know, Malaysia has a very big automotive industry, and they want to turn 90% of this into electric vehicles at the same time. So there is we can see that Malaysian government has set the objectives for this, and we believe that we will slowly get to the point.
Stellios and Gregors.
Yeah, I think it will be very interesting to see what happens, because Malaysia, of course, historically has gone through a fantastic development, largely based on oil. And the pride of Malaysia, I mean, what foreigners mostly know about Malaysia are the Petronas Twin Towers, right? So the national oil and gas company. But actually, yeah, now that renewables, energy storages, all this is becoming so cheap, it's definitely going in the other direction. But the mindset is still quite sort of oil focused, and we did quite an interesting street survey where we asked people on the street some energy questions, and people basically almost like a knee-jerk reaction said, yes, Petronas should keep drilling for more oil and gas. And then the next question we asked, do you think climate change is a big threat? And they said yes, and they just didn't see the connection there. So, because you can't believe one and also the other, right? And then we also asked people, how much would you think it would take to fully power Malaysia with renewables? How much of the land would you have to use? And most Malaysians thought a lot. Some even thought we needed more land area than in all of Malaysia. I think the average answer was 30% of the land was needed, but in reality, you only need less than 1% of Malaysia's land to fully convert to renewables. So there's a lot of misconceptions, a lot of, I think, oil industry mindset, and it's a new world, and I think it's happening fast. I mean, just look at those figures that Sean quoted, and if you go to, let's say I'm from Denmark, the electric cars everywhere, right? Norway, I think it's 90% of new cars sold are electric. It's coming. So
All right.
brace yourselves for an exciting future.
Yeah, thank you very much. I want to know whether Dato Sri Johan Raslan would like to say some final words before we close. And I really want to say thank you to the participants that have attended this morning. We have a whopping 80 people that attended today on the closing session with Sean Armstrong coming in from the US under the US Department and the US Embassy. I would also like to thank Climate Governance Malaysia. I think the topic of 100% electrification is a great topic to bring in and segue after all discussions on 100% on the energy transition. And I'm really looking forward to the changes that are coming. Dato Sri, are you still online with us? Bear in mind, it's almost 3 a.m. in the UK. I'm not sure if he's still with us.
Of course I am, and it's been riveting. I won't show my camera, but thank you so much, everybody. I really appreciate this, and I'm sure all the audience have quite a large audience we have today, and quite an excellent range of people have dialed in for this. So thank you very much to everybody here today, Sean, Dr. Stellios, Gregors, and of course you, Serina, and all the organizers from Climate Governance Malaysia. Thank you.
Yeah, so that certainly was a very insightful discussion. So thanks again, everyone. Thanks, Serina, and the panelists as well. So ladies and gentlemen, Gentlemen, so as you read out this electrifying webinar series on transforming community into efficient and sustainable spaces, I encourage you to take the knowledge and inspiration gained from this series and apply it in your everyday life. So recordings of the session will be up on YouTube in the next couple of days, along with an accompanying blog post up on our website. So do keep an eye out. So thank you for joining us on this journey, and feel free to subscribe to our newsletter and follow our LinkedIn page to stay updated with our upcoming events. So hope to see you soon. Thank you. Bye-bye.